Alright, so the next thing I want to talk about is housekeeping. That means keeping our work area clean. Notice that this isn't as clean as it could be. I'm going to clean it before I start. When you guys are done, you need to clean it up to be cleaner than it was when you started. Alright, so I'm going to take my little paintbrush from 1924. That's before most of you were born, I'm pretty sure. And clean my table. When I'm done, we vacuum the floor too. We set up so that our part is in a vise. There's other ways of clamping your part down too, but the vise is the easiest way for us. So I take my part, I make sure that it's at the top of the jaws. Some of you are probably going to find parallels or something to put under it to hold it nice and straight. I just basically give it a little feel to make sure that it's not high anywhere. Tighten it down so it can't go anywhere. Set up for my smallest drill size because that's the highest speed at which the machine's going to run. So I go through and find my little tiny drill bit here that is hole B, 3/32 of an inch. Put it in the drill chuck. Tighten it up with the key. I unplug my drill, open it up. With it unplugged, it can't bite me. There's no way for somebody to accidentally turn it on. Nobody's going to get hurt changing the RPMs. I'm going to set this for very high RPMs, but in order to develop the formula, years and years of practice happened, and they determined that cutting speed times 4 divided by the diameter of the drill bit is the speed at which the part's supposed to be turning. So cutting speed for mild steel is 100 times 4 is 400. 400 over this drill bit that is 3/32 is going to be really freaking fast. Okay? So I'm going to set this to, wait a second, there's nothing here that says really freaking fast. Can you guys do the math, figure out the RPM, and look at this to see what RPM it should be spitting at? I'm going to just set it at 2080 RPMs because I'm thinking that's pretty close, but prove me wrong, please. I've loosened the motor so it can slide. I'm changing my RPMs by changing the belt positions. I'm looking for D2. D is the bottom one here. That's D. And 2 is going to be the second from the top here. Oops. All right, so position D and 2. I tighten up the little thumb screws. I shut this, and I should be ready for RPMs now for the smallest hole. Clint, you forgot the center drill. Well, the reason I forgot my center drill is because the center drill is too big for the smallest drill, so it doesn't matter. I did that on purpose. I'm going to find my small hole here, line up so that it's close. Make sure that I can go down as far as I want to. If I need to, I can actually raise the table too. I'm going to start it up. That's my first hole drilled. What did I forget? I know what I forgot. Oil. We don't want the drill bits to wear out. We give it a little bit of oil so that it keeps it cool and so it lubricates it. This is a very, very small drill bit. I did something called pecking, where we go slowly up and down. It clears the chips. It keeps it cool. This tiny drill bit wasn't spinning as fast as it should. You don't use much pressure. You let the drill bit do all the work. You'll notice I haven't broken my drill bit, and it's still nice and sharp for that one hole, but I should have used a little bit of coolant on it. Make sure you use coolant. My next drill bit. This one comes out. Next size up is going to be this one. This one says 1/8. That's G drill. G hole is way over here. 1/8 is the same size as the tip on my center drill. Should I use the center drill? I think I'll use the center drill instead of this drill bit. Now what I'm going to do is there's a little angle here on the center drill. I'm going to make that angle bite into the part just a tiny little bit, and it deburrs my part for me, makes it so there's no sharp edge there. Do you remember what I forgot last time? Pretty sure you do. I'll give you a hint. It's orange. Little drip of oil. Turn on the machine. Did I forget to change my RPM? I think if you did cutting speed of 100 times 400, over diameter of 125, you'd find out that it's still around that 2000 RPM mark. Okay? So what I'm going to do now is do my math. Can you pause for a second? I just wound up in a little bit of trouble because my eyes are getting bad and I can't read this drill anymore. How do we know the drill size? Well, I'm looking for, on our print, 832. It looks like number 29. So I'm going to find number 29 drill on here. 29. Our diameter is 0.136. So I take a precision measuring tool. I measure across flats. Oh my goodness, this is the drill bit that I was looking for. I've just measured and verified across the cutting edges to make sure that it is number 29 at 136. So I'm going to cut this hole next after I use the center drill. A lot of people slow this down with their hands. That's a no-no. We don't touch rotating machinery with our hands. I'm going to find my next hole size. You might notice I'm not telling you my hole size or position because I want you guys to go to the charts and I want you to go to the blueprints and I want you to understand rather than me walking you through the whole thing. Okay, so I'm going to shut off the camera now and finish drilling the holes, and then we'll come back to the next step. Just on a side note, I'm drilling my biggest hole. It's right around 1/4 inch. Right? It's 257, I think. So when I drill this hole, if the drill bites and it tries to pull this part out, don't try to catch it with your hands. Just shut it off. Then we can undo it, get it out, and fix everything up for you. Any drill bit that's bigger than 1/4 inch, we're supposed to be using a clamp like this one. Slides in, clamps on our vise. This one's been played with enough that it doesn't quite work anymore. But what we're supposed to do is make it so the vise can't spin on us and hurt somebody. If you look at your textbook, it says to make it so that this piece of the vise is touching the column so it can't spin. Alright, so I'm going to continue on with this, pecking. That's the last of my holes. Now I'm ready to tap. Okay? So when I go to tap, if I'm in a production shop, I'm going to have a tapping head set up on this machine. It's going to have a clutch built into it, and it's going to tap each hole independently. As I pull down, it'll turn one direction. When I go to lift up, it'll spin the other direction and take it out. Some people put their tap in here and don't tighten very tight. Then it'll slip a little bit, but it damages the jaws on our chuck. So what I want you to do is, by hand, on one of our vises, use, what's the L-shaped thing called again? Well, I want you to read that too. So what we're going to do is we're going to take our, now I'm drawing a blank. Yeah, square. We're going to take our square and we're going to make sure that every tap is straight up and down in all angles, in all directions. Your teacher's going to check and make sure that when these holes are tapped, they're tapped straight. Okay, so you're going to make sure that you square them first. You could use your student card. You could use a credit card or a debit card. It's just got to be a perfect right angle in order to tap these holes. And don't forget to use tapping solution or else you're going to break your taps, and they're in your kit. Okay, don't break your taps. Pause.